So this is labeled as Module 2, but it's actually Module 6, not 2. And what these are here, these are Greek letters, and I think towards the end I stopped saying what they are because I think they don't change their name. So this right here is a lambda. This right here is a mu. Lambda multiplied by mu equals speed. Lambda multiplied by mu equals c, or the speed of light. 1 per second, or second to the negative 1. Actually, I say this 1 divided by seconds. Okay, that's probably better. Okay, 1 divided by seconds, or second to the negative first power, also known as reciprocal second. 1 second to the negative first power, also known as reciprocal second. Lambda equals c, the speed of light, divided by mu. And mu equals c, the speed of light, divided by lambda. Mu is equal to c, the speed of light, divided by lambda. C equals 3 times 10 to the 8th power meters per second. Equals 751 nanometers. Equals 751 times 10 to the negative 9th power meter. Let me write that in here. Meter. Or 7.51 times 10 to the negative 7th power meters. Okay. Equals 3 times 10 to the 8th power meters per second divided by 7.51 times 10 to the negative 7th meter. Okay, hold on a second. Okay, that's right, I have it written right. Equals 3.99 times 10 to the 14th power reciprocal seconds, or second to the minus 1 power, negative first power, or hertz. Example, E, or energy, is equal to H multiplied by mu. H is Planck's constant, or 6.626 times 10 to the negative 4th joules times second. Okay. You can also say multiply. I use multiply and times interchangeably. I hope that doesn't confuse you, but times and multiplied mean the same thing. Multiplied is probably the preferred term. Not that I'll use it all the time, but it's probably preferred. Okay, mu equals c divided by lambda, and again we have the slash here, that means division. E equals h, Planck's constant, multiplied by c, speed of light, divided by lambda. And again, because these two are right next to one another, it means they're being multiplied. Okay, E equals h, Planck's constant, multiplied by c, the speed of light, divided by lambda, equals the quantity of 6.626 times 10 to the negative 34th, or to the power of negative 34 joules times second, multiplied by 3 times 10 to the 8th meters per second, divided by 404 times 10 to the negative 9th meters, equals 4.92 times 10 to the minus 19th, or 10 to the negative 19th power joules. Okay, so down here we have a bunch of stuff all put together. It means these are multiplied by one another. 1 joule equals 1 kilogram, multiplied by meters squared, multiplied by seconds to the negative second power, or 1 kilogram meter squared per second squared. Thus, 1 joule times second is equal to 1 kilogram meter squared per second squared times second. It's equal to 1 kilogram meter squared per second times second to the negative 1, or 1 kilogram meter squared per second. And you know what? I need to change this because this needs to be in parentheses. It's not clear that that second is not in the denominator. So if you would, I'm going to highlight that. Make that change if you can. Okay, moving forward. 4.92 times 10 to the negative 19th joule per photon multiplied by 6.022 times 10 to the 23 photons per mole equals 2.96 times 10 to the 5th joule, or 296 kilojoules. All right. Energy of a photon, or you could even say E subscript photon, is equal to H multiplied by C divided by lambda. Now, all of these, I keep saying these, but the fact that h is equal to Planck's constant and c is the speed of light and lambda is wavelength, those are in the notes. So you don't even have to say what they mean. You can just say h multiplied by c divided by lambda. And that'll work because they should know what they mean. I tell them in the notes. Delta E, change in energy, equals negative r subscript 8, 1 over n subscript f squared minus 1 over n subscript I squared. And again, here in the script, I kind of explained it, but I think that might be too much. They should be able to get that information from the notes. NF equals 2, NF squared equals 4. NI equals 4, NI squared equals 16. Delta E equals negative R subscript H multiplied by the quantity of 1 over NF squared minus 1 over NI squared is equal to negative 2.18 times 10 to the negative 18th joules multiplied by the quantity of 1/4 minus 1/16 equals negative 4.09 times 10 to the minus 19th joules. Okay. Lambda equals hc divided by E subscript photon is equal to the quantity of 6.626 times 10 to the negative 34th joules times seconds. Okay, wait, I'm going to start over again. Lambda equals hc divided by E subscript photon is equal to 6.626 times 10 to the negative 34th joules times seconds multiplied by 3 times 10 to the 8th meter per second divided by 4.09 times 10 to the negative 19th joules is equal to 4.86 times 10 to the negative 7th meter equals 4.86, equals 486 nanometers. Okay. All right, and then down here, this is kind of when so E equals mc squared, lambda equals h divided by m multiplied by v. Now this is v for velocity. This is not mu. It's maybe hard to see, but this is v for velocity. Lambda equals h divided by m multiplied by v. 2,200 pounds multiplied by the quantity of 1 kilogram per 2.2 pounds is equal to 1,000 kilograms. 70.0 miles per hour multiplied by 1,609 meters per 1 mile multiplied by 1 hour per 3,600 seconds is equal to 31.286 meters per second. Lambda is equal to h divided by meter times velocity is equal to 6.626 times 10 to the negative 34th kilograms meter squared per second divided by 1,000 kilograms multiplied by 31.286 meters per second is equal to 2.12 times 10 to the negative 38th meters kilograms squared per second squared. Oh dear me. Okay. I don't know what these are here for. I guess you just need these. These were taken out of context here. Kilogram meter squared per second squared, kilogram meter squared per second. And these quantum numbers and the electron configurations, they're really not that hard. You just read from left to right. dxy, dxz, dyz, dx squared minus y squared, and dz squared. So those superscripts of 2 mean squared. That's not the case here for writing electron configuration. We just read the numbers from left to right. 1s2, 2s1, 1s2, 2s2, 1s2, 2s2, 2p6, and the 3s, which can hold 2 electrons, 3s2. So all of these electron configurations, you're just reading from left to right. Okay, I'll just do this one for fun. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d5. And let's see. Here, what I would say, aluminum, 1s2, 2s2, 2p6, 3s2, 3p1 equals neon in brackets, 3s2, 3p1. Okay, now you can just say Al here. K. Ugh, just say K. Really stands for an element, but I don't, let's just leave it as K. Actually, I don't like that. I don't like that idea at all. Okay, so here just say aluminum and then 1s2, 2s2, 2p6, 3s2, 3p1, Ne in brackets 3s2, 3p1. Same thing here, say the symbol K or potassium 1s2 equals argon in brackets 4s1. Tc or technetium. And then just read from left to right and then just say Kr in brackets. So as you're reading these, just say the name of the letters in the brackets. Kr in brackets 5s2, 4d10, 5p2. Ar in brackets 4s2, 3d9. Okay, down here where we have charges, Na positive, Ne in brackets, Cl minus, Ar in brackets, Cu plus, Ar in brackets 3d10, Fe2 plus, Ar in brackets 3d6, Fe3 plus, Ar in brackets 3d5, 1s2, 2s2, 2p2. So anywhere you have electron configurations, you want to go ahead and just read it left to right. All right, I think that is it for Module 6, even though, as I said, this was labeled as Module 2, this is Module 6.